Okay. So hey guys, my name is Nate Lindstrom. I'm VP of Solutions Engineering for NS1. So not last night, but Tuesday I gave a talk on DNS, and I mostly stood in front of my laptop and typed. This one is completely different. It's all slides. And so the point of this is actually not to give you a primer on like how to set up AWS, but rather things to watch out for. And then when you start actually setting up AWS in a production environment for a company, I've got a handful of things to do correctly from the get-go, as well as some tales of woe about what happens when you don't. So EC2, which is the Elastic Compute Cloud, which is the sort of the core of AWS or Amazon Web Services, it is actually based on Xen. So if you want to understand a little bit better how EC2 works, you can check out Xen. You can even run your own Xen cloud instances. I've done that plenty of times. If you look at some of the kernel version information that you can see under EC2, it'll have mention of Xen all over the place. It's very clearly based on Xen. So EC2 instances can use either something called instance storage or elastic block store, EBS. EBS is persisted to disk in certain situations, which I'm going to come to in the next slide. Instance store disappears when the instance is shut down. So if you have instances that are started very briefly for some purpose, like for example, if you're using Jenkins for continuous integration or continuous deployment, and you start a bunch of EC2 instances up, do something on it, and then when you're done with the instance, you don't care about its storage, you use instance store, because it will just take care of itself and disappear. On the other hand, if you're running something where you might want to power it off and then start it back up later and not have lost all the data that you stored on it, then you want to use EBS. Now, the thing to watch out for with EBS is it is not committed to disk until you do a snapshot. So this is something that I have seen burn people in production environments. If you've got a lot of data that you're writing to an EBS volume and you are not snapshotting it, there's a very good chance that it will become corrupt or you'll lose it if something goes wrong on the back end. So what I always recommend doing is just make regular snapshots. It's now very easy to automate. You can just Google like automatic snapshots. You don't have to even do it out of cron anymore. You can just schedule it directly out of AWS and just snapshot it at least nightly. The most often I've ever snapshotted something was running an Elasticsearch cluster of several thousand EC2 instances with close to 10,000 EBS volumes, and we snapshotted them every 15 minutes because we could not afford to lose the index. The index took like a week to build from the MySQL master, so yeah. EC2 instances usually have really bad entropy. So there's two random number devices built into the Linux kernel. There's dev-urandom, which is a pseudo-random generator, so the randomness is not very good. And then dev-random, which is supposed to be truly random. Now, here's the thing. When dev-urandom is being heavily drained, when something is reading a lot of entropy from it, the kernel just produces more fake entropy and feeds it into it. On the other hand, dev-random is a blocking call, meaning when it runs out of entropy, whatever is trying to read from it is put to sleep by the kernel. And Xen instances in general suffer from this, but EC2 included, which is the DOM0, which is the physical machine that actually has multiple virtual servers on it, is taking its entropy and parceling it up among all of the virtual servers. And so each server, if you have, say, 20 EC2 instances running on a single physical box, and you actually have no idea how many there are because Amazon doesn't give you that visibility, but let's say there's 20, you're getting 1/20th of the total available entropy on that machine, and you will run out of it pretty quickly if you're doing anything that involves cryptography. So if you're running an HTTPS server, and you're doing any amount of traffic, then all of the SSL connections, setups, and teardowns are going to be consuming entropy. And SSHing into the instance consumes entropy. And so actually the way I've seen this manifest is with mysterious lockup problems, where, for example, at Salesforce, I had a bunch of web servers that would just intermittently, for no reason that we could figure out, they would just stop accepting HTTPS connections. They would just hang. And the worst thing was when they were hung, I could not SSH into them to figure out what was going on because SSH was hung. And that was the clue that ultimately we put together. We're like, oh, they're running out of entropy. So everything that involved SSL or SSH was dead. So there's this daemon that you can get called HaveGED. And what it actually does is it measures jitter in the CPU branch predictor, which is to say when the CPU is doing branching of instructions, it measures minute timing characteristics between branching instructions. And the reason CPU branching would vary slightly is because all of the other virtual machines are calling interrupts. The other machines are also consuming CPU resources, and so there's enough sort of noise going on the physical machine that it impacts the slice of CPU time that your virtual machine is getting, and this actually leads to incredibly good entropy. So with this, generally you won't run out of entropy, and if you suspect you are, you can monitor it because there is a file under /proc called, I think it's called entropy_pool. Not directly under proc, it's a bunch of subdirectories. I don't remember the exact path, but you can find it. An entropy pool should contain a number somewhere in the neighborhood of at least 100, maybe 200. When it drops below 100, you're headed towards lockup, and I've seen it get down into like the 20s, and then the machine will just randomly freeze as it runs out of entropy.
That's on your virtual instance?
Yeah. So speaking of neighboring EC2 instances, something else that can happen, especially in a production environment where you are performance sensitive or where you're doing a lot of load on your EC2 instance, is you're going to have what are called noisy neighbors. And these are literally EC2 instances that are on the same physical machine as your EC2 instance, which are consuming more than their fair share, so to speak, of CPU or, more importantly, network I/O. So if you've got somebody on the same allocation unit, the same actual physical server as you, and you can't tell other than the fact that your EC2 instance will be starved, and they're doing something like slamming tons of network throughput through the physical interface of the physical machine, they can actually starve your EC2 instance, and you'll end up with a machine that is underperforming all of its peers. So the way that I've detected this in the past is by not only monitoring each of my individual web servers to make sure they were functional, but to also compare their performance with their peers. And so if I had one web server that was, say, performing 30% slower than all of its peers, then there was a good chance that it was dealing with a noisy neighbor. And literally the only way to fix this is to stop the instance and then start it again. Not reboot it, because if you reboot it, it stays in place. If you stop and start it again, there's a chance that Amazon will shift that EC2 instance to another physical unit. And it's literally what my boss at the time, I think he came up with the term restart roulette, or maybe you read it somewhere, but it literally boils down to that. You just have to stop your instance, wait a minute, start it again, see if it's better. If it's not, stop it again, start it again. Sometimes I've done that like a dozen times before the EC2 instance finally moves somewhere quieter. So EC2 instances live in regions and availability zones. So a region is like US East 1, which is Virginia, or say US West 1, which is Northern California, or US West 2, which is Oregon. Availability zones are letters that are appended on. So like US West 1A is availability zone A within Northern California. US West 1B is availability zone B. The theory behind this is A, B, and C are at least guaranteed to be on different power circuits. They might be in the same physical data center. These days, given the size of the regions that Amazon is operating, there's a good chance that availability zone A, for example, spans multiple buildings. And B also would span multiple buildings. Same for C. There's generally 3 AZs, or availability zones, per region. But at least if you are doing something where you need redundancy, make sure you're spinning up EC2 instances in different availability zones. So have one running in A and one running in B at least. And at least they're then on different power circuits. So this is something that sometimes gets overlooked, and it causes troubleshooting to be a huge pain. But when you are logging on EC2 instances and the EC2 instance dies, you then can't get to your logs. So almost invariably, once you pass having maybe a dozen EC2 instances, you really need to have centralized logging. So logging needs to be either shipped to a central syslog server, or maybe you're sending it off to Splunk or Sumo Logic or something like that, but get it off of the instance. And something to remember is it's really useful if, when you're writing entries into your log file, that you record the instance ID as part of the log file string. Otherwise, I've seen it where I've inherited like a Sumo Logic setup where we had millions of lines worth of logs coming in every hour, and none of them were tagged with the instance they were coming from. So there was some percentage of errors coming in, and I had no idea which of the thousands of machines I was operating were actually throwing the errors. So just remember that. Stick the instance ID in your logs. Now we're getting into a little bit more advanced stuff. This is probably not applicable if you're just playing around with AWS or EC2 for learning purposes, but as soon as you head into a production environment, turn off SSH. So quite literally, if it's done right, all of your EC2 instances should be fully interchangeable. They're just cogs in the machine. You never should log into one. There should be no unique snowflakes. And so literally just shut SSH off. And then that does two things. One, nobody can break into your instances via SSH. And two, it prevents you from logging into your own EC2 instance and making one-off fixes on it and then suddenly being in the situation of, oh crap, I have this special machine now. Now what do I do with it? Do I back it up? If I lose it, what happens? Like, this is how this very deep rabbit hole usually starts, is when somebody makes one-off changes on one machine and then that machine becomes special. So don't do that. Just shut SSH off. And make sure your automation that's starting the SSH or starting the EC2 instances and deploying code to them or whatever else is functioning correctly. Bake your credential files into the AMI. So the AMI is the Amazon machine image, and this is the master image that contains the OS that actually starts up the EC2 instance. So when you start an EC2 instance, you have to pick an AMI or an Amazon machine image. And that gives you, at a minimum, like a Linux install or a Windows install. I've seen this time and time again come back to haunt companies where the credential files are actually like part of their GitHub repo or something. And sooner or later they leak, or somebody checks out the GitHub repo somewhere insecure and someone gets a copy of it, and the next thing you know, they got hacked. So a company I used to work for, OneLogin, was compromised about a year ago. And this is exactly how it happened. The root credentials for AWS were baked into a GitHub repo, and they were forgotten about, and they were recovered by a malicious actor who then was able to start up EC2 instances in OneLogin's AWS account and then very easily siphon data out of the database. So the interesting thing about security groups, there's two things about them that are interesting and kind of irritating. One is they do not cross regional boundaries. So a security group is going to be specific to US East 1, will have no bearing at all on US West 1 or US West 2 or EU East 1 or something like that. And so when you get into a situation where you've got machines in multiple regions and they need to have specific firewall rules talking to each other, so like if you have a database server, let's say in US West 1, and you've got web servers in US East 1 and they actually need to be able to access the database, you now have this problem where you're going to have to come up with firewall rules that are hard coding IP addresses in, which is horrible because EC2 is all dynamic IP addresses. So honestly, the best solution is this third-party software called Cloud Passage Halo. And it basically runs an agent on every EC2 instance. And then when an EC2 instance changes IPs, it dynamically adjusts all of the IP table firewall rules on all your other instances to track the change. But it costs money. The other thing is that once you set up a security group on an EC2 instance, you can't ever change it. So if you screw up the security group assignments on an EC2 instance, your only recourse is to terminate the EC2 instance and start over. So just something to be careful about. So this is sort of more, again, broadly applicable advice when you are at a company or in the workplace doing something with AWS, and that is everything should horizontally scale. So the difference in horizontal scalability and vertical scaling is that if you can only run your software on one machine, and as load increases, you need better performance, your one choice is to make that one machine bigger. More RAM, faster CPU, more cores, whatever. Well, there's very much an upper limit to that. You can only have so big of a machine. Like, they only make so many cores, and you can only put so much memory in a machine. Horizontal scalability is you have a bunch of little machines, and when you need more capacity, you just add more little machines, and it's infinite, because you can run an almost infinite number of machines in horizontal scaling. So there's a later slide where I actually sort of repeat this, but basically if you've got an application that can only run on one instance and it just requires a giant instance, don't put it in Amazon. It's a complete waste of money. Run it on a physical box. But on the other hand, if you can figure out a way for your application to have lots of little copies of itself, then you're going to fit really well in AWS. So EC2 instances are all DHCP clients, so Dynamic Host Configuration Protocol, which is how IP addresses get dynamically assigned. And every EC2 instance gets two IPs. It gets one that is a non-routable RFC 1918 IP, so this is something in the 10 dot space the 172.16 something space or the 192.168 space. And then there's a public IP that gets mapped to the private IP, and then Amazon is doing special split horizon magic inside where if you're talking between EC2 instances, they'll communicate over their non-routable local IP. But if you're going out, and going out, by the way, includes crossing regions, then you go out to the public IP, and thereby also incur data transfer charges. So something called an elastic IP or an EIP is a way of reserving a specific public IP. Well, you don't get to pick the specific IP. In other words, you reserve a public IP and it never changes as long as you pay for it. And you can attach it to an EC2 instance at will. So typically with a normal EC2 instance that's not using an EIP, when you stop it and start it again, its IP addresses change. With this, if you stop it and start it, it will come up without the EIP attached anymore, but you can then reattach your EIP and then its public IP becomes consistent again. This starts to matter in certain scenarios depending on the services you're running, but AWS does not support anycast. And that's actually a big problem for running DNS, for example, out of AWS. So you're not going to be able to do anycast. If afterwards somebody wants to know what anycast is and you're still awake, I can explain it, but it requires a little bit of drawing on the whiteboard. So US East 1, which is the Reston, Virginia area, this is where AWS deploys all of their code changes first, so it tends to be the least stable. So I always recommend people run your QA and your dev environments and your sandboxes in US East 1 and run your production in US West 1 or 2. Don't run it in US East 1. They have historically had the most outages. So a reserved instance discounts the cost of running an EC2 instance. However, you have to buy a reserved instance slot for either 1 year or for 3 years. So the challenge is if you've got an EC2 instance that's a particular type, like let's say M4.x large, and it's in a particular region, then you can say, all right, in order to pay less by the hour for running it, I'll buy a reserved instance. But the reserved instance is tied to the type and the region. So then if I've had this happen to me before, where I bought reserved instances for a bunch of stuff, and then it turns out with a later code deploy that the instances were no longer powerful enough. So I needed bigger instances, and now all my RIs no longer fit the instances I was running. So now I had already bought RIs, and I was running instances at the per hour rate again. I'd really wasted money. So it kind of requires that you predict your compute needs for like the next year or worse, the next 3 years, and then sort of buy the appropriate slot. So just be careful. There is now a way actually to sell them on the marketplace and sell them back in case you screw up and buy an RI that you end up not being able to use. All right, so moving off of EC2, Elastic Load Balancing, or ELBs, are Amazon's load balancers that they invariably want you to sort of front-end groups of EC2 instances with. They're running a highly modified version of HA proxy. So if you want to sort of understand under the hood how ELBs work, you can look at HA proxy's website and their config examples and stuff. And I don't know the exact nature of the modifications. As far as I got with actually talking with Amazon about this was basically the guy I was talking to basically was like, well, yeah, it is basically HA proxy, kinda. I was like, okay, close enough. So Elastic Load Balancers use auto-scaling behind the scenes. So AS or auto-scaling is basically where you can set criteria where you say if a load passes a certain high watermark on my instances, then I want to start more instances automatically using a particular AMI or Amazon Machine Image. ELBs do the same thing. An ELB is guaranteed to be 2 EC2 instances minimum, and then as throughput through the ELB increases, it scales up the number of EC2 instances. They're not called EC2 instances. How you see it is the ELB magically acquires more and more IP addresses, and you'll end up with an ELB that has like 30 IPs. And then as traffic drops, the number of IPs shrink, and it goes eventually back down to 2 when it's idle. Which means that something to watch out for is that ELBs scale average load that as is perceived across all the backend servers. So if you're running, let's say, 10 EC2 instances with an ELB in front of it, and the average is really fairly low because one machine is idle for some reason because it's broken, and so it's dragging the average down, then the ELB won't scale even though it really needs to. It's not actually monitoring like the peak load on every EC2 instance and then saying, oh wow, one of these is really high, I need to scale. It looks at the average. So that can burn you if there's a problem and all your machines are not evenly receiving traffic. This also is because ELBs dynamically scale the number of IPs you're using up and down. You need to either use a CNAME in DNS to reference them or use an alias record. So an alias record is not an RFC DNS record type, but Route 53 supports them. NS1 supports them, my company. Dyn has something similar. They don't call it an alias record. They call it something else. And they're relatively widely supported, but the upshot is you cannot look at your ELB and say, oh, it has 3 IPs, let me write them down, and then let me create 3 A records. Because within 5 to 10 minutes, the IPs are all going to be different, and your DNS is going to be broken. So use a CNAME or an alias record. And by the way, after this, I will, Sam, if you don't mind, I'll email you the slides, and then feel free to distribute them. I know there's like a bunch of content I'm running through, but you can pull up the slides later if you want to look at them. So the difference between CNAMEs and aliases, just briefly, is CNAMEs is where your DNS points to, as I explained on Tuesday, one label points to another, and then to actually get to the final answer, which is an IP address, you need to do multiple lookups. So the client would need to look up the CNAME, and then it would need to look up the CNAME target, and potentially that has more targets. An alias, on the other hand, offloads that on the server. The server does all the legwork, and then returns the IPs as if it were an A record.
Isn't that essentially recursion?
Sort of. But with certain problems. The lookup is indeed recursive. You call it and you say, I need the A record for this ELB, and it is rather slow usually because it's doing recursion for you, and then it comes back and says the IPs are this. The problem is all the geo-targeting information is lost because the server did the lookup. So if there's geo-targeting happening for the IP addresses, it's geo-targeted to the server that did the lookup and not you. So it does break stuff. Or can break stuff. RDS is relational database service. So typically, if you want to run like a MySQL server or a PostgreSQL in AWS, they will push you towards using RDS. And they're actually an internal customer of EC2. I actually had some conversations with the team, and so they literally, they're using EC2 instances. They're using their own AMIs. So they're special sort of doctored Amazon machine images, but they're actually just a customer of EC2. And when EC2 has an outage, it takes down RDS as a result. They only use Elastic Block Store for storage, which makes sense because if you shut your RDS server down, and having your database go poof would really suck. And then you get into real money here. So if you get into a situation where disk performance is poor, possibly because of noisy neighbors or just because your application is badly coded and it's slamming the server with a lot of selects and inserts at the same time or something, you can pay for something called provisioned IOPS, which is where you're actually paying for a minimum commit of I/O operations. And AWS will sell you very large I/O pipes to your Elastic Block Store disks, but they cost a fortune. As an example, at Salesforce, again, because it was the biggest one we ever ran, I had 2 massive MySQL servers, a master and a slave. Both needed to be highly performant for the website. So we were running 24 EBS volumes on each, which were arranged in RAID 10, and we were paying for 10,000 provisioned IOPS per volume. And my monthly AWS bill for the database servers alone was $175,000. But they were screaming fast. But in hindsight, that was just nuts. But hey, we were in AWS, so we had to pay it. All right, so simple storage service, or S3 for SSS, it's WebDAV. So this is basically create, read, update, delete operations over HTTPS or over HTTP. So if you want to know how WebDAV works, that's the URL. But there's a few interesting gotchas. So S3 buckets by default are created in what S3 calls the central region. There is no such thing as a central region in AWS. Central is US East 1. So you can specify that the buckets be made elsewhere, which I tend to recommend because S3 buckets are completely overloaded in US East 1 because most people don't bother to specify where they go, so they all default to US East 1. As I previously mentioned, US East 1 is the least stable region. So you're better off creating S3 buckets in the West region, I think it's called, which is, I think, US West 1 at the moment. And then directories in S3 are not directories. Directories in S3 are file name prefixes. So if you create a bunch of files and you put them in a directory, that, let's say the directory is named ABC, what actually happens is all of your files are still in the flat organization of an S3 bucket. There is no directories, but now all of them are prefixed with ABC. And then some non-printable character to separate the directory from the file name. This has ramifications because the way S3 allocates files on disk is based on the file name. So if you take all your files, and let's say they all have very random names because they're all like random image uploads, and you put them in a folder, now they all have a common prefix, which means they're all going to be written to the same disk. And so if that one disk dies, you lose everything in your S3 bucket. So both for performance, because you want to have your reads spread across multiple disks, and for reliability, you want to have as random of file names as possible. Usually what I see people do is you'll have an actual file name that makes sense, and you'll shove it in a random directory, which causes it to have a random prefix, and that spreads the files all over the multiple disks. So Glacier doesn't get a lot of exposure, but it's actually really cool. So Glacier allows you to you can automatically expire objects out of an S3 bucket into Glacier. And Glacier is long-term storage, and it's really, really cheap. It's like when I say cheap, it's like cheap on the order of like 5 cents a gigabyte a month. And you can store stuff there forever. However, as I say here, it is cheap and reliable, which is true. I haven't heard of Glacier losing any large number of objects ever. Or I haven't heard of them having like corruption issues. And it is cheap. And there's this saying in IT, which is you can choose fast, cheap, or reliable. Choose any two.
Can people download from Glacier?
Mm-hmm. But the retrieval time is not guaranteed. They may be really slow. You might make a request, and I think Amazon says something like it may be several hours before they can satisfy it, kind of thing.
I might settle for that.
Yeah, if you don't need it instantly, and it's a great place just to dump backups, you know.
Well, see, my students had $1 junk, and I put it on Mega, and the college blocks Mega.
Oh.
Now I've scattered all over stupid places.
Oh, yeah, this might be a way to do it.
Yeah.
Set up an S3 bucket with like an expiration policy that says after 1 week, put it in Glacier, and then just throw stuff in the bucket.
Okay.
Yeah. So if you can have cheap, fast, or reliable, and we're choosing cheap and reliable, that means it's slow. Now, Amazon Route 53 is exactly the same thing. It is cheap and reliable. So you can actually run a significant amount of DNS traffic through it for maybe 10, 20 bucks a month. And it is extremely slow. When I do catch point profiling tests against other DNS providers, because it's something I do frequently as part of my job, Route 53 is always an easy opponent to go up against performance-wise, because they're usually on the order of 150 to 200 milliseconds slower than everybody else. But if you don't care about how quickly their DNS responds, they're, like I said, extremely cheap, and they have had 100% uptime like now for the last 8 years. They've never had an outage, so they're very reliable. Now, Route 53 has something called latency-based routing. I'm going to kind of blow past this because I don't know that it's really of interest to anybody, but it's usually something when I'm at a meetup, I will push it harder because it's a selling point where NS1 beats our Pulsar product beats latency-based routing hands down. But just briefly, they have this idea where they can say, all right, well, we can route you we can route the incoming person, the incoming client, to the closest Amazon region based on latency. And they kind of do a lot of hand waving, and it sounds really cool because you don't have to take measurements or anything, it just happens. But what really is happening is they're using something called smooth round trip time, or SRTT, to figure out what name server actually handled the query coming from the end client, and then they use Bgp Hop Count, or route cost, between that name server to the closest Amazon region to figure out the closest region to that name server, and then they call the whole thing latency-based routing. I actually think it's mostly crap, because SRTT to the fastest name server tells you nothing about actual HTTP performance. or website performance. It only tells you about DNS performance. And then BGP route cost from the name server to the closest Amazon region doesn't tell me anything useful at all. It just tells me the BGP route that the DNS server was taking to talk to the Amazon region. So it's mostly marketing. Anyways. So still talking about Route 53, renaming a record via the API is not an atomic operation. So at some point you'll probably be using Route 53 maybe in a production environment, and watch out. I have seen a rename attempt blow up because it deletes the record first and then it creates the new one. I have seen the creation fail, which means you then just nuked potentially a vital record out of your DNS server. And I have witnessed one major outage happen to a company as a result of this. It's actually how I found out they weren't atomic. Never, ever, ever, ever use your IAM credentials, or never ever use your root credentials, rather, to do anything other than create IAM credentials. So the root credentials are the credentials that you create when you first sign up for AWS. You should then immediately go to the users section and create a user and then log in as that user account and do everything else. If you don't do that, then somewhere down the road, you'll be like, oh crap, I never did that. You know, we should really stop using the root credentials for everything in production, like create IAM accounts. And usually by then it's too late because some idiot has baked the root credentials into the code somewhere. And then it becomes a really horrible search operation where you're trying to find the root credentials everywhere that they went. And you can change the root credentials on an AWS account, but you can't go back. So it's really scary, and I've been in this position, it's really scary to say, okay, I think we found all the root credentials throughout our millions of lines of code and changed them. And so now we're going to change the root credentials on the AWS account and hope to God it doesn't burn down, because if it burns down, there's nothing we can do to fix it because we can't go back to the old root credentials. You don't want to be in that position, so just don't use them. Immediately create an IAM account and use that for everything. Similarly, always enable multi-factor authentication on your IAM accounts, or if that's too much of a hassle or costs too much because you need, usually you need token devices, at least enable it on the root account at a minimum. Because if your root account gets compromised, you're sunk. Once again, one login last year got hacked because somebody compromised their root credentials. By the way, they're going out of business largely because of that, because their customers started leaving in droves. They're an identity management company and their root credentials got popped. I mean, that's bad. So always use multi-factor authentication. And that actually sort of goes for all your accounts. Like set it up on your iCloud account, set it up on your Dropbox. Anything that supports two-factor, turn it on. If your bank does not support it, switch to Chase and call your bank up and tell them you took all your money out because they're idiots. I've done that twice now. I like Chase because they actually do security correctly. There's other banks I'm sure that do as well. I just happen to not have tried them yet. I like Chase. Anyways, so something called CloudWatch can actually alert you when there's problems with your EC2 instances or your volumes or basically anything, your S3 buckets for that matter. And you can actually attach automation to it just natively in AWS. It takes a little bit of coding and a little bit of work, but when you're again in a production environment, it makes a ton of sense to say, I want to monitor everything using CloudWatch, and then the things that I see that happen either fairly often or that are easy to fix, let me set up automation to actually fix them. And then if the fix fails, then I page the on-call guy. And then the part that always gets missed usually is everybody skips the post-mortem, which is when your automation breaks and production is impacted, you need to figure out, like, why didn't the monitoring catch it? Why did the automation break? Why did the on-call guy not fix it? Why didn't he wake up or something? But do a post-mortem, figure out what went wrong, and then fix it permanently again. If you skip that step, then eventually you get locked into this firefighting cycle where production is always at least smoldering, and you're always trying to put it out. And then you end up working, 80-hour weeks and working through Saturdays and Sundays, and you're like, I hate my life. I don't know where I went wrong. Well, where you went wrong was you didn't do a post-mortem the first time it blew up. Also kind of related to that is it's a good idea to set up billing alerts on your AWS account because it's really easy for accidents to happen. So one could be an auto-scaling misconfiguration where you just suddenly, something happens and there's like a little tiny minor rise in traffic, and so your auto-scaler goes and starts 10,000 instances for you. I've seen that happen once. The one I've seen happen a bunch of times is where developers have access to AWS, usually for testing purposes. They might be in a different region than production. And they not being familiar with AWS, they will do something like starting up a monster-sized instance that is, something on the order of like, there are instance types that are like $100 an hour to run. They'll start up a couple of those for testing and then forget about them, and they'll just sit there and they'll run all month. And then your Amazon bill comes and you're like, my normal Amazon bill is $30,000 a month, and this month it's $180,000. What happened? Well, if you have billing alerts set up and you know your average bill is like, say, around $30,000, set up a billing alert for 40, so you got a little bit of a margin. And when you get alerted 1 week into the month that you've already hit 40 grand, you can go on a search for the EC2 instances that are killing you. Better to find out ahead of time than try to explain to your boss why your AWS bill quadrupled. CloudTrail is a way to do auditing of changes that are made by anybody, either through the API or the web interface. And this is always a good idea. As soon as you're not the only administrator making changes, there's two of you, set up CloudTrail. And have it go to a versioned S3 bucket. And the idea behind versioning means that somebody goes in the S3 bucket and alters the logs, that fact itself is audited and auditable and logged in the S3 bucket. It may sound distrusting, but trust me, at some point you'll be in a situation where something has gone wrong. Everybody claims they didn't touch it. Clearly somebody touched it. And if you don't have this set up, then you have no idea who touched it, which in a bad environment can turn into the least popular person is then assumed to be the person who touched it, which could be you. I'm not saying it is, but it could be. I've been in that situation, politics being what they are. So it's a good idea to have auditing in place because it covers your ass just as much as it covers everybody else's. Like, it's good to know what happened. And then finally, last slide, if you've got a monolithic application, don't put it in AWS. So by monolithic, I mean, as I sort of alluded to earlier, an application that only vertically scales. So another example of this is I worked for a company many years ago called Boku, B-O-K-U, and we had this gigantic application written in Perl that did everything. And it was one single Perl file with a bajillion libraries or Perl modules. And I was part of a team that was hired specifically to break it apart and rewrite the entire thing in Java. And I was the tech ops side, so I was setting up the servers and everything. In fact, I used Zen and built a private cloud to host all of the new Java stuff. But for a long time, all of the business functions, the website, the admin page, the sign-up portal, everything ran out of this one Perl file. It would have been madness to try to put that into AWS because it could have only have run on one instance, which meant you would have needed one of those $200 an hour instances to run it, which is like, why? But after they successfully broke it up into, 10 or 12 small Java programs that each did a thing, then it became a total candidate to put in AWS because then you could run lots of them horizontally. All right, so that is the sort of whirlwind tour of what to do and what not to do in AWS. Does anybody have any questions, or did anything seem odd or not especially make sense? I know I kind of went quick.
I want to hear about Anycast.
Okay, I can explain Anycast. All right,
I
so
don't understand how it cannot work at Amazon. That would seem so important.
they do Anycasting internally for their own stuff. They just don't let customers Anycast. It's pretty common in cloud environments. Google Cloud Platform has the same problem. They support regional Anycast for they have two kinds of load balancers. I don't remember the names, but one of them is I think it's called the Cloud Traffic Director or something. That supports regional Anycast. So you can do Anycasting like in Europe. But you can't have it also Anycasting in America. They do this weird thing. Anyway, so the way Anycasting works, first let me explain BGP very briefly. So let's say this is us. Let's say this is the server that we want to get to. And let's say this is 1, 2, 3, 4. So in the sort of typical drawing of how a network connection works, you say, well, the person goes to the server, which is highly, highly simplistic. The reality is that the path that your network traffic takes, where's the eraser? My finger is not working.
They don't have one, actually.
Oh, okay. Well, here, what I'll do is I'll switch to another color. The reality is the way this actually works is there are a number of routers through which your packet passes on its way to the destination. So ignoring this black line, because that is no longer in use. It turns out now we have 2 routes to the server. So in order to figure out which route to use, BGP, which is assumed to be running on these routers, BGP standing for Border Gateway Protocol. So BGP is Border Gateway Protocol. And what it is when a router boots up, it listens for BGP announcements from neighboring routers, and these neighboring routers say, hello, I'm this router, I have a route to 1, 2, 3, 4. And this one then says, okay, excellent. And then it will announce to its neighbors, I have a route to this router, and this router has a route to 1, 2, 3, 4. And thereby the mesh sort of self-populates. So what happens is, assuming that we're sitting down here, let's say we actually have a router that's just ours, and these things are actually talking to this router, then when we send a packet onto this machine says, well, I actually have 2 routes to get to this machine. This one has a route cost of 2, and this one has a route cost of 3, meaning there are 2 hops to reach the destination on that route, and there are 3 hops to reach the destination on this route. So if this route explodes, so this route would be preferred because it's shorter in terms of hop count. If this explodes, then our router is able to say, well, that's fine. We can actually still get to the destination. We just are going to take a slightly longer route. And this is the basics of how the internet works. Now, it turns out that this IP address is unique within just the space of these routers, meaning this is the router that actually has knowledge of the 1, 2, 3, 4 IP address space. This router also has knowledge of the 1, 2, 3, 4 address space. This router does not. This one just knows how to get to it via this router, et cetera. And so the way you can get around this even better is you can say, well, you know what? From the perspective of the end user here, there are 2 routes to the same server. What if we do this? What if we run another server and we give it the same IP address, and we hook it up to that router? And that route is now gone. And this one is hooked up to that router. From the perspective of this user, it is still a route with a cost of 2 to get to IP address 1, 2, 3, 4, and a route with a cost of 3 to get to IP address 1, 2, 3, 4. You can't tell that it's now 2 machines with the same IP. That's Anycast. So you literally take 2 or more machines, you put the same IP addresses on them, and you announce those IP addresses through unique routes. And then you end up with this really nice situation where you can take these servers and you can put them around the world. Any given user will go to literally the closest server just by default, thanks to BGP. And closest, of course, being defined in terms of Bgp hop count. So if I go here, let me just pull this up. So if I go to ns1.com/anycastednetwork, this is exactly what we're doing. So we have 24 POPs located around the world. And that's the little red, they're kind of hard to see, the red dots here all over the place. So each of those POPs contain anywhere from a few hundred to a few thousand servers, and all of them have the same IP address. So when you go to access our network, you go to one IP address. It just happens to be replicated in all these different places. And so, if I'm sitting down here in South America, I'm going to go to the Brazilian POP because that's probably the fewest BGP hops to get to. I'm sitting in the US, then if I'm over here like near San Francisco, I'll go to San Francisco or San Jose. If I'm in New York, I'll go to the New York one. And actually, we just launched a product with POPs inside mainland China. So now if you're in China, you actually go to a local POP. But China is this weird case because China does not allow Anycast. They're the only country that doesn't. So if you're inside the Great Firewall and you're inside mainland China, they don't permit Anycast because Anycast, as you can see, makes it difficult to figure out the source of content because the content may be highly distributed across multiple machines with the same IP, which means if you want to regulate where the content is and you need to know who to arrest if you disagree with the content, you don't want Anycast. You want Unicast, which is single IP on each machine. Every machine has a unique IP. So that's why that's the case in China. But in the rest of the world, Anycast is really common. Does this make sense? Any questions about this?
So how does information get populated between servers?
I mean, between the routers?
No, between your...
Oh, that's up to you to figure out how to do that. Automation. Yeah.
It must have another address, which is unique, so you can...
Yes.
Okay.
Yes. So like all of our machines are multi-home. They have unicast addresses that are for, well, they have multiple. Each machine actually technically has 3 IPs. There's a unicast address for administrative purposes, so we can SSH into the machine and see what's going on. There's a unicast address, which is for receiving Mongo database pushes, as well as sending back RabbitMQ messages, because that's how we track query count. And then there's the Anycast address, which receives all the DNS queries. So yeah, you are absolutely right. Yeah, somebody else asked me that one time. I was like, well, if you have all your machines at the same IP, how do you get on a specific machine to fix it? Like, do you just SSH over and over and hope you get lucky? It's like, no, you actually do need individual IPs. You need unicasted addresses too. All right, guys, well, if there aren't any questions, then I will stop putting you to sleep. Yes?
I got a question.
Sure.
Sorry, I missed your last talk about the DNS.
Oh, no problem.
Well, I got a question really quickly. I'm running a virtual machine, the EC2 machine on AWS, and since it has dynamic IP address, I register a domain name on lowip.com, dynamic DNS provider.
Right.
And it worked, and then I install a daemon on my EC2 machine.
Right.
And it report the IP, update the IP every time you boot. And it works surprisingly well because from my understanding, I read some documentation from other DNS provider like GoDaddy. They always said when you update your domain, you need to wait up to 48 hours to update the IP address.
Right.
But when I use the dynamic DNS, it never happened. It always happened in just a few minutes. Could you please explain how that works?
Sure. So the 48-hour number, I actually tell people 72 hours usually. So that is when you register a domain, you're paying money to a registrar, and they are literally carving off a small slice of com or net or org or whatever it is and giving you your domain name. Like for $9.95 a year, you can have something.com, right? They talk, so when you do that, they make an API call to something called a register, which is depending on the top level domain you picked. So if you pick com, the register is operated by VeriSign. The register gets the API call from the registrar, authenticates it, and then creates the necessary DNS delegation entries in the com authoritative servers. So that is the DNS servers which are authoritative for the entire com domain. And there's now going to be a new record in there saying, for example.com, go talk to your no DNS or your DNS servers, your dynamic DNS service. There are no SLAs whatsoever, public service level agreements. There are none published whatsoever between registers and registrars. And so the general rule of thumb is I just tell everybody it's going to be up to 72 hours because your registrar might be having problems, or they might make the API call to the register and the register doesn't respond, whatever. Once upon a time, most of the registers, including VeriSign, they did updates to the root servers, I think, once a day. So depending on when you registered, if you missed the once a day update, you waited at least 23 hours and some odd minutes for it to come around again. Now they're doing pushes. Com, anyways, I think is pushing updates like every 15 minutes. So that's why it happened basically instantaneously for you, even though they said 48 hours. Or the reason GoDaddy said 48 hours, they're just covering their bases. But it's usually nearly instant. Every time I've registered domains lately, my DNS has taken effect inside of like an hour. But I still tell people up to 72 hours. Does that make sense?
But why the lowip.com, the dynamic DNS works so fast?
Well, so it's working at a different level. So the root servers for the entire internet, I don't know, let's say your domain is example.com. And let's say your EC2 instance is www.example.com, right? So you've got an IP over here. And so keeping this up to date against your IP of, whatever it is, 1, 2, 3, 4. This is your, what's it called? No DNS?
Dynamic.
Dynamic.
No IP.com?
No IP, right. So, the agent running on your EC2 machine notifies them, and they immediately update the DNS record for www. Well, they are authoritative, I presume, for www.example.com, but the reality is that this has its own set of what are called TLD servers, which are authoritative for it. So the actual portion of authority for noip.com is just the part of .com that you're paying for. And then, in fact, there is the root servers, which manage the whole of the internet. These are the root servers. So when you registered example.com, the DNS change that GoDaddy warned you might take a long time was the change being made here to call into existence your domain. Then thereafter, changes that you're making on a completely different provider are nearly instantaneous because you're using noip.com. But like if you transfer this domain, let's say you said, well, I don't want to use GoDaddy anymore, I'm going to transfer it to Namecheap. Then you would be touching this set of name servers again, and the whole 48-hour rule would apply again. So it's really, it's the root servers. So if I looked your domain up, I would talk to the root servers. So this is me. The root servers would delegate to the COM TLD servers, and these would delegate to the NoIP servers. And so this is where your dynamic updates are occurring that are really fast. These are static because you already registered your domain, but if you registered another domain, you'd be touching this level again, and this level is not as fast. So that's why there's threats of varying times that you're being told.
Okay. I taught a class where students had to make a domain and had to change the address many times over the course of a couple of days.
Yeah.
And invariably, for about 20% of the students, the DNS got lost to where false updates would go around and back and forth, and several times it would never resolve. And the latest updates would never get through.
Right.
And I never quite understood why that happened.
What service were you using for DNS?
GoDaddy. Had
Okay.
GoDaddy to start from. But the thing is, there's an IPv6 certification process where it would first go to a v4 address, then a different v4 address, then a v6 address, then a different v6 address, all over a few hours.
Okay.
And 20% of them got so hosed, they just had to buy a new domain and start over. Because even like in 2 days, it would never come right.
Well, I will say in general, GoDaddy sucks. Like, I just wouldn't use them.
But see, the reason I had to use them is because for years they were the only ones that had IPv6 glue records.
No, that's
I don't know
true.
if they all do now, but
Yeah, we basically all do now. But
I
yeah,
hope so.
yeah.
They were the first ones that had that, and you
a good
could
point.
not burn this credential without having an IPv6 glue record.
Okay.
Yeah,
Well, then, yeah, what can you do?
yeah, but I thought DNS would sooner or later straighten out, and it didn't. Another thing happened at college about 5 years ago. The website was up, and then it was down, and then it was up, and then it was down for like 2 weeks. And it was one of my students at Cloudflare that figured it out. Somehow, there was a DNS update that had the wrong update number coming from some of our servers. So people would update the new one, and then old information with a later number would come override it, and then the new one would come out, and it would just flap back and forth.
Okay. The serial number of the zone. Yeah.
Yeah.
Yeah. Okay. Yeah, you can do that to yourself. You have because the reality is the updates don't compare if the serial number is higher or lower, just if it's different. So if you have two masters and one of them is old,
That's what
they'll flap.
Had to like restore from backup or something. So
Yeah.
now the two masters had inconsistent data, and they would just randomly flap.
Right. The funny thing is that nobody implemented it right. The RFC actually says that in the SOA record, you name the source of truth, the one master that rules them all, basically.
Yeah.
And the RFC actually says that when you have a situation where the masters don't agree, you're supposed to look at the SOA record and you talk to that master, and that's the one you trust. The problem is nobody implemented that.
Yeah.
So you get the flapping behavior. Yeah.
Yeah.
Yeah. I think all problems are caused by not implementing the RFC.
I don't think so. Sorcerer's Apprentice in TFTP was from obeying the RFC. Because
Yeah.
the RFC said every packet packets have to be acknowledged,
Right.
and if it fails, it has to be an error message. The error message has to be acknowledged, and the acknowledgement has to be acknowledged. And now you're doomed.
That's cute. Yeah. God, I remember setting TFTP servers up so I could remote boot diskless clients. What a pain that was.
Yeah.
Yeah.
There was a similar one in IPv6, because people use 64s for everything.
Right.
So you have a billion addresses each end of a cable, so you can send something from an address that doesn't exist to another address that doesn't exist. And it will go to one, it must be at the other end, send it over here, it must be at the other end, send it back here. The line is now completely full of one packet bouncing back and forth, and there's no TTL at that level.
Oh, right.
It's out of service.
That reminds me of a QA send mail server that started sending bounce messages to a production send mail server, which in fact bounced the messages back. And I just got this accelerating loop of bounce messages until the disk went and everything just fell over. Yeah.
It's easy to do that.
Oh yeah, it is. Yes.
I got one more question.
Sure.
I'm a beginner of this cloud computing stuff. I just started using AWS and Google Cloud
Cool.
about 2 months ago, just because they offer a 12-month free trial. Could you talk about what's the difference between AWS and Google Cloud and some other cloud platform?
So at a very high level, they're all the same thing. You're just buying CPU time. The differences are in the naming conventions. They call their technologies different things, but they're all basically virtual compute instances, virtual computers running on physical servers somewhere. So what makes AWS different from GCP versus DigitalOcean Droplets versus, I don't know, Packet networks or something is the API is different. The surrounding services are different. So like AWS has S3 and it has RDS and it has IAM credentials and all these different things. I mean, there's this whole long list if you look in their console, right, of all the different services you can set up. Google Cloud Platform has roughly equivalent ones and they call them something completely different. So what ends up happening is one of two things. Let's say you're a company and you're building this out. Either you decide from the get-go, okay, we need to be cloud agnostic and we need to actually be in multiple cloud platforms for purposes of redundancy. So if Amazon has an outage, we're not down because we're also in Google. The problem then is you need to figure out what's the lowest common denominator that you can do on both, which is not going to be all the features. And then you need to write usually some sort of middleware that sort of sits above it and abstracts to both APIs and says, well, I need to create a virtual instance, and it will do the appropriate Amazon AWS call and the appropriate Google Cloud Platform call. And if AWS supports, some whiz-bang feature that GCP doesn't, then you can't use it because you don't have it in Google. So this happens a lot because companies want to be cloud agnostic and they want variability. On the other hand, the other thing that happens just as often, in fact, far more so, is they go all in on AWS. And at some point, you're using so many AWS specific features that you can't possibly leave the ecosystem. That's how they lock you in. Because if you're using EC2 and you're using auto scaling groups and you've rolled your own AMIs, your Amazon machine images, and you're using Beanstalk, Elastic Beanstalk to configure stuff, and you're using what's called Redshift, which is one of their database services. There's no way you're going to port that into Google Cloud Platform without thousands of man hours of coding stuff. So I can't really say, well, the differences are this and this, because there's so many of them. It's just mostly terminology. It's like if you go on Google Cloud Platform, you say, all right, well, I need a load balancer. What's it called? It's not going to be called, ELB, or Elastic Load Balancing. It's going to be called Google. I think it's called Cloud Balancer or something like that. But what's it do? It distributes packets among virtual servers that are sitting on the back end. The same thing ELB does. So that's all. If you wish to become I don't know what we call it, a cloud expert in a particular platform, then I would pick either AWS or GCP, because GCP is growing really fast.
What about Azure?
I don't recommend anybody be a Windows administrator who just end up hating life. But I'm an MCSE, by the way, and I say that. So, yeah.
Well, I don't know. It's really more messed up than Linux. I mean, they're both pretty good at driving you nuts.
True. Linux, though, I think you can have a better chance of maybe figuring out really what's happening and fixing it. Because worst case, and I've done it a few times, worst case, you can read the source code.
Yeah.
Which could be really painful, but so AWS or GCP, or if you are already Windows specific or you know Windows really well, then to Sam's point, Microsoft Azure. If you want a project to do over the summer and you want to come out of it knowing Linux better than 99% of your peers, look up something called Linux from scratch. It will take you a long time, and if you complete it, when you are done, you will be able to run circles around anybody else who claims that they're an expert in Linux, because you will have literally built Linux from scratch, including things like compiling a very small compiler, so you can compile a larger compiler, which is capable of compiling a very small glibc, so you can build a bigger compiler. Yeah.
Joe McCrae teaches a class where he takes you through ethical hacking after like 4 months, you're getting real pen test jobs, and like the 6th week, you have to do this. Build your own Linux.
Okay, that's cool.
Yeah.
Yeah. This is called Linux from scratch, LFS.
Yeah.
I did it about, I think I went about 2/3 of the way through it. And then I ran out of patience. But, and then I also read a book called The Design of the Unix Operating System, which is not cheap. It's not on Kindle. You can only get it in hardbound or paperback. It's like $60 from Amazon. But it is worth reading if you plan to ever be, say, a system administrator or a DevOps person or something like that. And if you're going to go into a technical interview, having read that book, you can answer absolutely everything about how Unix works. Because that'll introduce you to how the scheduler works in memory and swap and I/O and process management, like the whole 9 yards. It was written by a guy who actually was part of the original AT&T System 5 Unix build. He actually knows what he's talking about. Yeah.
What's your book?
The Design of the Unix Operating System. Yeah, it's blue and white. It's worth, if you're going to start reading books like that, the other book to read is TCP/IP Illustrated Volume 1. And not Volume 2 or 3. TCP/IP Illustrated Volume 1. It's one of those things where it's like, if you're going to do well, I'll give you an example. So I had an interview, I don't remember where now, sometime back. Let me plug the computer back in. I'll pull the book up so you can see it. Years and years and years ago, I had an interview for a senior system administrator position, and I don't know, will that turn back on its own, or?
There's a remote control you could hit.
Oh, okay.
If it doesn't, it came on.
Oh, perfect.
Yeah, now I put on my news links too.
So I was at a technical interview many, many years ago, and the question that I was asked was, describe in as much detail as you can what happens when you type www.google.com into a web browser running on Linux. And I tanked really bad on that one because I didn't really understand it. I did a lot of hand waving and stuff. And anyways, that was the only technical interview question I got, and I did not get the job. But so I ended up, over the course of the next, I don't know, year or so, I read The Design of the Unix Operating System. I also read TCP/IP Illustrated, and had a lot of, oh, now I get how that works sort of moments. And then about 2 years later, or I'll pull it up, Design of the Unix Operating System. There it is. So it is, yeah, it's $76. Wow, it's gone up. It's not a cheap book, but it is certainly worth reading. And then the other one I mentioned was Amazon.com, TCP/IP Illustrated, Volume 1. So there's Volume 2 and 3, and those are not worth reading because those are really about how to implement TCP/IP in the Berkeley System Design, or BSD, which I don't think any of us want to do. So to finish my story, sorry, because I got distracted. So I tanked that interview really bad. And about 2 years later, I had another interview, and I had read The Design of the Unix Operating System previous to it, and it was at Yahoo. And I met with a guy who I was warned ahead of time. He didn't like anybody, is what I was told. And he asked me exactly one question. And his question was, if you run this command on Linux, ls greater than foo, will the file foo appear inside of itself? Why or why not? And I answered it over the course of about 15 minutes, and he cut me off and he said, okay, you're hired. And I worked at Yahoo for a number of years. That was the only technical interview question I got. And explaining why it does or does not appear inside of itself is literally not the topic of a meetup I give, because it takes about an hour to fully flesh out what is happening in process management on Linux, in disk I/O management. Like, there's a lot of complexity under this, but there is a definitive answer. And if you read the design of the Unix operating system, you'll actually be able to answer that in like eye-bleeding detail. So if you ever get asked something sort of along those lines, you can just like blow the interviewer away.
Is that how to ace your technical interview?
Yeah.
That was a fun time.
Yeah, I like that one.
There's some fun Linux tricks.
Yeah. Yes.
You just mentioned Linux from scratch. Is it a book or
It's a website.
website?
Yeah. I think there's a PDF book that you can download also, but it's all free. Yeah.
This reminds me of one that happened to one of my students. He had a hidden file in his home directory that he didn't own. So in his home directory, he executed chmod on .star.
Right.
Okay. It matched ... the owner of everything, everybody else's home directory.
Right.
Now that only happens on Ubuntu and no other kind of Linux, as far as I can tell, looking it up, because that's evil.
That actually doesn't make sense to me. If it happens on Ubuntu, it happened on everything. Because they're not doing anything, as far as I know, really weirdly unique with the file system. Did you do a sudo chmod?
Yes?
Well, then all bets are off. You traverse all the way up to root and kill everything.
Well, that's what happened.
Yeah.
But it looked, from what I could read, that it wouldn't have had another. I couldn't test it on other versions.
Okay. You can always start an EC2 instance up and shoot
Remember,
yourself in the foot really quick.
You can. Absolutely.
Yeah. The other one I've seen happen a few times is where somebody does, like sudo, like rm -rf,
Oh man.
like slash, and they meant like something, and they accidentally got a space in there, and then they had something else. You're like, why is it taking so long to finish? It's like, oh God. I hope you have a backup.
Have you done the Cisco program?
Which one?
Where you show something, the CCNA.
Oh, no, I haven't.
Yeah, there's in the very first class, there's a command like this,
Okay.
where if you put in a space, you destroy the whole OS on the router. And it's like the very beginning students that don't know anything, and they always kill half the routers. And you're like,
Why do they start with that?
they're trying to back up your config, which is a basic move, but if you put in a space, it wipes it over the real config.
Oh. Wow.
Yeah,
Bad.
Cisco is pretty cruel.
Yeah. Okay, any other questions? All right, guys, thanks so much for coming out. I appreciate it.
Very good stuff.
Thank you.